Beep, boop, ah, yeah! Today we're continuing to work on our AI and we're gonna add the possibility for them to cast spells so they are able to kill each other, and that's going to make it way more interesting than what we had in the previous video. So let's get to it. So in Unreal, we're mainly going to work in the blueprint unit AI. So in here we have BP unit AI. We're gonna open it in 2 seconds, but first let's create ourselves a new structure that we're gonna use to keep track of which spell we want to cast. So let's create the new structure right here. I'm going to name it S_unit AI spell casting data, and then we're gonna open it to add the variables we need. And here they are. So first I have a boolean telling me if the spell is valid, so if the spell contained in this structure is valid or not. Then I have the enum for my spell, so which spell it is. Then I have 2 endpoints, so the origin index and the target index, which is first the location where we want the unit to be when it casts the spell, and then the location where the unit should cast the spell onto. So the origin index, target index, and finally we have the spell score, because we're going to use a score to decide which spell is the best and which location to cast the spell is the best for that unit for this turn. Because let's say a spell touches 10 units at the same time, well, we want to add up all the damage we're gonna do and then decide, okay, that spell is a pretty good spell to cast this turn. So yeah, we're just going to add a bunch of numbers together to decide which spell is the best, and we're going to keep track of that inside that variable. Perfect, now we can save the structure, close it, and go inside the BP unit AI. And here we're gonna start by creating ourselves a new graph for the spell casting. So here it is, new graph spell casting, and we're gonna move all the function related to the spell casting inside that graph. So I'm gonna go back in the AI flow, cut all those functions right here. So decide which spell to cast, move to spell casting location, and cast spell. We're gonna do that today. So let's move that inside the graph spell casting right here. Let's compile. Okay, good, it works. And here we're gonna do the same thing we did in the previous video. We're gonna go one step at a time. So we're gonna start with the decide which spell to cast. So all those functions, we can move them out of the way and focus on this one first, because that's the first step. And the first thing we're gonna do is look at the design. So what do we do when we want to decide which spell to cast? Okay, first we're gonna reset the structure variable. We don't have the structure variable right now, but we're gonna create it. And then at the beginning of the flow, we have to reset it because that variable is going to contain all the data we did in the previous calculation for previous spells. So we are trying to find a new spell, so let's reset the data from scratch, so that way it's not going to interfere with that new calculation. Then once that variable is reset, we can generate the reachable, because we want to know all the possible origin location for the spell and then decide which one is the best one. Because let's say the unit can move on the left a little bit, okay, is this a better location to cast the spell? Yes, no. Maybe if the unit can move on the right, is it a better location? Yes, no. We don't know. So that's why we have to generate all the reachable, that way we can take all of them into account when we are calculating the result for the spell, which spell is the best. Then we're gonna wait for the reachable to complete as usual, and then we're gonna calculate the best spell. So for all the possible origin index, for all the possible target index for the spell, we're just going to add some numbers together and decide, okay, is this combination of origin and target the best one yet? Because let's say we move on the left a little bit and we cast a spell. If we cast it from that location, it can hit like, let's say 5 units at the same time. So that's a pretty good spell to cast. But maybe if the unit moved a little bit more on the left, so let's say 2 tiles instead of 1, the spell could hit, let's say 10 units instead of 5. So that's a really good spell to cast. So that's why we're gonna decide, okay, let's cast it from there instead of the previous location. Anyway, we're just gonna have a bunch of calculation. We're gonna take into account everything, the cost of the spell, the damage possible, if we kill something, things like that. We're gonna add a bunch of numbers in there, and then it might take a little bit of time, because if there's a bunch of different combination possible between origin and targets, that might end up taking a lot of time. So we're just gonna wait a little bit, add a little bit of delay in there, just so the game doesn't freeze. But we're not gonna focus on that first. We're just gonna generate all the data, and then if it causes performance issues, we can optimize that afterwards. And then once that's done, it should mean that we decided which spell we want to cast and we are ready to cast it. So we can complete this step and go to the next one, which is asking the unit to move to the good location to cast the spell and then cast it. But for now, we're gonna decide which spell to cast. So now the first step is to reset the struct variable, which we don't have. So let's create a new variable for it. I'm going to name it the AI spellcasting, and it is of type S_unit AI spellcasting data that we created at the beginning. Okay, good. So now we have the variable and it's time to reset it. So we can just simply do a set like that. It's going to reset the content of the structure. I'm just going to move the decide which spell to cast done out of the way because we don't need it right now. We're going to call it a little bit later, but for now we just have to reset the structure like so. Perfect. The second second step is to generate the reachable, so I'm just going to move on the right here and focus on the reachables right there. And actually, since we already did that a few times in the previous video, we're gonna go pretty fast. So first step is simply to connect ourselves to the callback and also disconnect it once the callback is called. So we are binding ourselves to the pathfinding completed right here. It's going to call the event, which is going to be disconnected right after. Good. And now we just have to call the findPath function, asking it to return the reachables. Okay, good. That's simple. It's the same thing as usual. So it's going to call this event once it's done with all the reachables. Perfect. So now we know where the unit can go on the grid. That's good. But we also need to know, okay, which spell can the unit cast with its current amount of HP point, movement point, action point, things like that. So we're just going to create a new function for it. So new function, GetCastableSpells right here. It's going to be returning spells right here, a list of spells. So it's an array of spell data. So we have all the spells that the unit can cast. And what we're going to do is simply get all the spells and loop through all of them. So we're going to compare all the possible spells for that unit. We're going to compare them to see, okay, which one is the best one. And when comparing all the spells, what's important to know is, okay, we have the spell. So that's the first step, which spell we want to cast. Then, okay, which is the best tile from where we can cast the spell? Which is the best origin tile? So is it here? Is it there? We have to check that. So we're going to compare all the origin right here, all the reachables that we receive. They are all origin indexes for that spell. So we can just loop through all the origin to compare them and decide which one is the best one. And then we also need to know which is the best target tile. So for each of our spell, we have different ranges. So in those ranges, for all the possible origin, we have to compare, okay, which is the best target for that origin tile. So if I'm on the left, maybe the best target is there. If I'm on the right, maybe the best target is there. So yeah, we have to compare all of them. So we need to know what is the range of our spell. So let's ask the combat system to give us the spell range. So right here, combat system, get spell range. For the origin index, it's simple. We just have to get the origin index right here that we have for the for each loop. And for the cast, well, it's from the spell that we have right here. So here we go, break the structure to access the cast. Good, so now we know the spell range of our spell. I'm just going to move on the right because we're gonna have a little bit more code afterwards. So yeah, now we just have to loop through all the possible targets because we need to decide which target tile is the best one for that spell to then decide, okay, is this the best spell to cast? That's a lot of calculation to do, and we're gonna do that into a new function right here. So this new function is going to use obviously the target tile, it's going to use the origin tile because it's going to affect the result, and finally obviously the spell right here. So we're gonna use all these three variables inside a new function to do the math for us. So here it is, calculate spell score and update spell casting. I didn't want really to return something at the end of the function. I think it's just going to be simpler if the function automatically updated the variable right here inside it. So that's why I'm not adding any output, only inputs, and the inputs are target, so the endpoint, obviously the origin as we said right here, and finally we have the spell right there. So spell data, here we go. So these are the three inputs we're gonna need, and we're simply going to call our function right there. So that function is going to take everything we calculated until now, and then it's going to update the structure with the new data depending if it's a good spell to cast or a bad spell to cast. Good. Okay, so that's the step. We're not gonna do the function logic right now because that's gonna be a pretty big function, so let's keep that for later. We're just going to finish the flow first. About that, I'm just going to go back a little bit. We have the decide which spell to cast done right here that we moved out of the way, and I'm just going to move it back in the flow and connect it after looping through all my spell. So I'm going to loop through all my spell, check all the possible origin indexes, all the possible target indexes, do the math, and once that's done, we can simply finish the step because all the data in the structures should be updated as we want. Good. So now we have the good structure and we can go and do the next step. But first, we're just going to go inside this event right here. So I'm just going to double click on the event, which is going to bring us inside the AI flow. And right here, I'm just going to add a little check to make sure that we're not asking the unit to move to spell casting location if we didn't find any spell we wanted to cast. Because if the AI spell casting right here in the structure, if the spell valid is false, it means that we didn't find any good spell. So we don't want to ask the unit to move and then cast the spell. We're simply going to end the turn right away. So let's add a little check right here to make sure that we're not asking the unit to do anything that is useless for it. And that's not too difficult to do, we just have to add ourselves a little branch right here to check if the spell is valid before asking the unit to move to spellcasting location. Otherwise, if it's false, we're simply going to decide where to end our turn, because we're going to bypass all the spellcasting logic because the unit is not going to cast any spell anyway. So let's just ask it to move to end its turn. Perfect, so that's done. Now we can continue to the next step, which is the move to spellcasting location. So let's focus on that one now. And actually, this step is going to be pretty simple because it's something we already did in the previous video. So we're simply going to ask the unit to move on the grid. So first we find the path to the origin location for the spell. So if we decided that a specific reachable was the best one to cast the spell, we're going to ask the unit to move there. So let's find the path to that tile. Here we go. We have the path. We wait for the path to be generated. And then we're going to ask the unit to move. Okay, that's super simple. We're going to wait for the unit to finish its movement. And then the step is going to be done. We're going to be able to go to the next step, which is casting the spell. So that's going to be pretty easy. And actually the first thing I'm going to do right here is to ask the unit, okay, do you need to move? So I'm just going to ask it, okay, do you need to move? The way I'm doing that is just by comparing the origin index of the spell with the current index of the unit. So if the unit is already on the origin index of the spell, it means that the unit is at the right place to cast the spell already. Don't ask it to move. So I'm just going to complete my step right here in the case that it's false. So if the unit is not on the right tile, we're going to ask it to move and do the rest of the logic right here, but otherwise it's already on the right tile, so we can go to the next step because the unit is done moving. We don't want it to move, so this step is done right there. And now I'm just gonna move on the right here to do the logic of the step, and actually it's not that difficult because we already did that before. So first we have to hook ourselves to the path finding completed because we're gonna ask the unit to move along a path, so we have to generate that path first. So let's bind ourselves to the callback and unbind ourselves once it's done, and then we have to generate the path. Here we go, that's simple. We have to do a find path, but this time for the target index we're gonna use the origin index of the spell. So we're gonna ask the unit to move from its current index to that location, which is from where we want to cast the spell. So the unit is here, we want it to be there, go there as usual. So yeah, let's do a find path. It's going to call this event once the find path is done, and then we just have to ask the unit to move, but we don't want to go to the next step until the unit is done walking. So we're just going to bind ourselves to also that event, the event on unit finished walking. So we're gonna wait for the unit to finish walking before going to the next step. And now that we're attached to that callback, we're gonna know when the unit is done walking, so we can ask it to move. So here we go, combat system, ask the unit to move, feeding it the unit obviously, and then the path we want the unit to follow. Okay, good, the unit is gonna go to the right location on the grid to be able to cast the spell afterwards. Good, so now the unit is done walking, it moved on the grid, we can simply complete the steps because that was the step to ask the unit to move to the origin location for that spell. So here we go, so now the unit is at the right location on the grid and we're done with this step. Okay, now it's time for the last step, which is simply to ask the unit to cast the spell, which is the step that we have right here at the bottom. So let's do that. And actually this step is really the simplest one. We just have to cast the spell, that's simple, and then we just have to wait a little bit just so the spell has the time to be casted, the animation has the time to play, and then we can complete the step. That's it, as simple as that. So I'm just going to move the spell casting done out of the way right here, and then in between I'm just going to ask the combat system to cast my spell. So in the AI spell casting right here in the structure, we decided which spell we wanted to cast. So here it is, I have my spell, I can feed it. We decided where we wanted to cast the spell from, so the origin index, that's it, and which was the best target index. So let's take it and feed it to the cast spell function. Here we go, now the spell is casted. We just have to wait a little bit, so I'm just going to wait a little delay, 0.5 seconds, just so the animation has the time to play a little bit, and then we can go to the next step. Perfect. So now we should be able to compile and save, and we should have the exact same result we had at the beginning of the video. We're not able to test anything because we didn't do the logic of these functions right here. But before doing that, I think it would be a good idea to make sure that we didn't break anything. So let's go see. Okay, so I have all my units on my grid. I'm just going to end my turn to start the AI, and we can see now, okay, they are looking for a spell, so that's new. And then they don't find any spell, so they are just looking where to move, and then they are moving. That's it. So they are skipping all the spell casting logic because we're not going to cast any spell because we didn't find any spell to cast, but that makes sense. Good. Okay, so now it's time to go decide which spell to cast for real. And we're going to start with the GetCastableSpell function. And actually this function is pretty straightforward. We're simply going to loop through all the available spell for our units and make sure that the unit can cast it. So if the unit has enough action point, movement point, health point to cast a spell, we're going to add it into that list. First thing I'm going to do is promote that into a new local variable right here. So RET for return. I have my new local variable and I'm going to move it out of the way. So here we go. So now we have the room to do the logic and then we can return the result at the end. And for the logic, we can simply loop through all the available spells. So inside the unit, in the unit data, we can have access to the available spell for that unit. We're going to loop through all of them. We're going to access the spell data of that spell. And then we're going to ask the unit, okay, can you cast it? So unit, can you cast the spell? If so, I'm going to add it inside that array. So add a branch and then add it inside the array if we can cast the spell. That way, before doing all the calculations for all the reachables and all the possible target indexes on the grid for that specific spell, we're just going to check, okay, can the unit cast a spell? Because if not, we're not going to do all those maths for no reason. Good, so now we can go inside the CalculateSpellScore, which should be a way more complex function. And actually here we're a little bit blocked already because we don't know if the spell touched someone. We want to calculate the score of the spell. We want to either decide if it was a good target or a bad target. But for that, we need to know, okay, did we touch someone? Because if we didn't touch anything, it's probably a useless target. We don't have to cast the spell right there. So we need a function that returns us all the units on the grid. That way we're going to see, okay, did my spell touch someone? Yes, no, maybe. We'll see. Okay, right now we have two functions. We have the GetAllUnits and GetEnemyUnits. We could combine both functions to retrieve all the units that are on the grid, but I think it's going to be a little bit more performant if we do another function for that, just a specific function to receive all the units on the grid. So I'm just going to create myself a new function right here, GetAllUnits, and I'm going to open the function, obviously, and inside it, I'm just going to pass it a boolean, telling it if we want to include ourselves, because it's possible that we don't want to include ourselves. Well, in this case, we don't want to. We'll see why later on. But yeah, we have an input right here telling us if we want to include ourselves, pretty much the same thing as we add in the GetAllUnits. And as output, I'm just returning a mapping, same thing as the other functions, which is going to contain all the units on the grid with their endpoint, so we know where they are on the grid. Good. First thing I'm going to do is promote that into a new local variable that I name RET, so I can easily add things inside it. And then I'm just going to move the return out of the way because we want to loop through all the units that are currently in combat. So in the combat system, get all the units in combat, loop through all of them. I'm just going to promote it into a new local variable that I named U. That way it's going to be a little bit more clean. And now we have a few checks to make. So first check is to make sure that the unit is alive, because we can't really attack a unit that is dead, so we don't want to include that unit in that case. And the second check is just to make sure that we are only including self if we want to. So right here, if the unit is not equal to self, we can return that unit. Or if we also want to include self, we're also going to return that unit. But if it's self and we don't want to include self, well, we're not going to return that one. But anyway, if it's true right here, I'm just going to return it the same way I did for all the other functions. So the GetAlly and GetEnemy, it's pretty much the same thing. So I'm just adding the unit in my mapping, and then at the end, once I'm done looping through all the units, I'm just returning the mapping at the end. Good. Now we can go back in the previous function right here, and we can use this new function to retrieve all the units that are on the grid. So we have other units right here. We're not going to include ourselves. I'm going to explain that a little bit later. And then I'm just going to promote that into a new local variable, all unit except self right here. So now we know, okay, we have all the units on the grid, and now we can really decide, okay, did this spell that we are trying to cast touch anybody on the grid? Because if it didn't, well, we don't really care. But actually, that's still not enough. Right now, we know all the units where they are on the grid. That's good. And we know the target index for our spell. So let's say we targeted the tile X. That's great. It's good if the spell is not an AoE spell. But if the spell is an AoE spell, maybe that tile is not even attacked by the spell. The spell maybe just splashed around it or something like that. So yeah, we need to know which are the attacked indexes, not only the target index, because the target index is very nice, but if it's an AoE spell, that's not enough. And there's actually a bit of code that does exactly that in the combat system already. So instead of just duplicating it, I'm just going to go there and collapse it into a function, because it's not in a function right now. So I'm just going to convert that into a function so we can call it easily from here. So let's go in the combat system real quick. So I'm going to go in my combat and open the BP combat system. And in here, the bit of code that I want is inside in the spell, in the CastSpell function right here. And I think it's the bit of code right there. Here we go. So this is the bit of code that is generating the attacked indexes for that spell. So it's checking if the spell is AoE. So right here, it's checking if the spell is not AoE. If it's not AoE, it's only using the target index. That's good because that's not an AoE spell. So that makes sense. But in the case that it is AoE, it's going to use the spell AoE range to generate the attacked indexes. That's exactly what we need. So we're just going to collapse all that into a function. I'm just going to select this and collapse that into a new function, collapse to function, which I'm going to name GetAttackedIndexes. And then inside the function, we have a few things to fix. So let's go in there right here. We can see that we have a bunch of errors because, well, we don't have all the variables yet. So we need a variable for the target index. So I'm just going to connect the endpoint to the input right here. So it can create a variable for us. I can rename it the target index right away. So target index, and I'm actually just going to rename the spell data to spell as input right here, just so it's clean. Oops, I clicked on something. Okay, here we go. So now I have my spell and my target index. I can reuse my target index here. So target index in the make array, and also the target index, it's already there, so that's good. Okay, and now we are returning the attack index here. Instead of setting them into a new variable, I'm just going to return them right away. So return, here we go, a return right here, connect the array, rename it to attacked indexes. There we go, and then connect it also at the bottom. So yeah, there we go. So if it's not AoE, it's going to return the target index in an array. Otherwise, it's just going to return the AoE of our spell. Good. Now we're just going to go back in the CastSpell function right here to connect the input and output properly because they are not connected yet. So the spell is good. That one is connected. We need the target index, which is already in the function. So get index, we have the get target index right here. And then we have the attack index that we're going to use to set the local variable that we have right there. So attack indexes. Here we go. Can just connect that like so. And that should be the same as before. I just need to clean it up a little bit because it's not that nice, but yeah, now it should not have affected the combat system at all. But we now have a function that we can use inside the unit AI. So let's go back in there to use it now. Go back in the unit AI, use the combat system called GetAttackedIndexes function that we just created. The output, we can promote it into a new local variable, attacked indexes, and then we can simply connect the spell and the target. So get spell right here, and then the target, so get target, here we go. Now we can just reconnect everything to make it a little bit more clean, and that should be it. Good. So now we have the list of all the attacked indexes, so all the tiles that are affected by the spell, and we have the list of all the units that are on the grid, meaning that now we can combine both those lists together to determine, okay, did we hit something for real, not just targeted something? Did we hit something? And then we can calculate the score based on that information. So, okay, let's start by creating ourselves the new variable for the score. So to remember how much the spell is worth right now. So new variable right here, it's a float. I named it total spell score, and I'm gonna go on the right here to initialize it. So how do we do that? I think it will be a good idea to initialize it negatively if the unit has to move to cast the spell. So if the unit is on the right tile, it's going to start at 0 points by default. But if the unit has to move, let's say 2 steps, we're gonna start the score negatively. So let's say minus 10 points or something like that. The unit is going to have a little bit of a preference if the spell can be casted from the current tile instead of having to move before casting it. So let's do that. I'm gonna start by checking the distance between the current index and the origin of the spell. So if we need to move, that distance is going to be greater than 0, and then I'm going to take that number, multiply it by -5 because I want it to be negative, and then I'm going to use it to set my default value for my total spell score. So if I have to move, that value is going to be negative, otherwise it's just going to be 0. And now it's time to update the spell score based on all the attacked indexes. So let's say we attacked 10 indexes. Maybe one of them has an enemy on it. We want to increase the spell score. But maybe another one of them add an ally onto it. So let's reduce the spell score for that one. Maybe there was another enemy, but that one was almost dead and you were going to kill it. So let's increase the spell score by a lot because it's more important to kill an enemy than save an ally. Something like that. And it's also going to depend, okay, am I removing action point point to the target unit? Am I adding action point to the target unit? Am I giving them healing? Am I damaging them? There's a bunch of maths we can do to affect the result, and that's what we're gonna do now. So I'm just gonna move on the right a little bit, and we have to do those calculations for all the indexes that we are attacking. So let's loop through all of them. I'm taking all my attack indexes and I'm gonna loop through all of them, and I'm just going to create myself a new local variable right here for the attacked index. That way it's just going to be a little bit cleaner. And now it's time to check if we actually attacked something, because if we casted the spell in an empty space on the grid, we don't really care about that because we just touch emptiness. It doesn't matter. It's not going to affect the score at all. So that's why right now it's time to check if we touch someone. So okay, we have a variable right here, the all units except self, that contains all the units on the grid except the current unit. Why is the current unit not in that mapping? It's because the current unit can move on the grid to cast the spell, because the origin index of the spell with that we receive at the beginning of the function, that origin index is variable. If the unit has to move on the left by one tile to cast the spell, the origin index of the unit, the current index of the unit, is that index right here. But if the unit has to move on the other side, that index, the origin index of the unit, is actually this index right here. So the index is variable. That's why I'm not adding the unit directly in the mapping. But to check if we attacked ourselves, instead we're going to compare with the origin index of the spell, because if the unit has to move to cast the spell, the unit is going to move before casting the spell. So yeah, it's just to make sure that we support the movement of the unit. So here it is. I'm going to check if I'm attacking myself. So if the attacked index is the same as the origin index of the spell, it means that the unit just attacks itself, and I'm going to save that into a new local variable. So I'm going to take my unit and save it into a new local variable right here, unit attacked unit. Here we go. So now we attacked ourselves. Okay, that's good. Actually, that's not good. We're gonna use that information to generate the score of the spell later on. But first we have to check, okay, in the case that I didn't hit myself, did I hit someone else? So in that case, I'm just going to check in my mapping, okay, do you have this index right here that I just attacked? If so, it's going to set a valid unit inside that variable, the attacked unit. So I'm either going to attack myself, or attack someone else on the grid, or attack nothing else on the grid if there was nobody there. And so that's why I'm just going to move on the right here, and I'm just going to check, okay, is the attacked unit valid? So did I hit myself, did I hit someone else, or did I just didn't hit anything? And in the case that I didn't hit anything, it's not going to be valid, and we're not going to affect the score at all in those cases. And now it's time to calculate the impact score for the index that we just attacked. How many points did that give us? Okay, that's gonna be a lot of calculations, because we need to know how much action point did the spell cost, how much movement point did the spell cost, how much damage did we do, how much healing did we do, did we just attack an ally, an enemy, did we just kill an enemy, did we just kill an ally? There's a bunch of things like that. So instead of just doing everything in this function right here, I'm just going to add myself a new function to do that. So new function right here, calculate the impact score, and I'm adding it to input. So the spell that we want to cast, here it is, I have my spell, and the unit that I'm attacking, so the attacked unit, and then we are returning the score at the end, so the impact score, which is a float. So okay, I'm just going to call my function right here, filling in the spell and the attacked unit. That's super simple, and that's going to return us the score. And now I'm just going to finish the flow before going inside this function. So here it is, I have my new impact score. What I can do is simply add it to my total spell score that I currently have. So my score is at -50, add let's say plus 200, whatever. And then once that's done, we can simply set it back inside the total spell score. So we're going to increment the total spell score for all the attacked unit on the grid. So if we attack 10 units, that value is going to be changed 10 times. And once that's done, we should have the final score of our spell. So I can just go back here at the beginning, actually at the end of my for each loop, and just to see, okay, I have my new total score for my spell. Is this score better than the previous spell we found? So if we found a spell that was worth, let's say, 200 points, because it was a good spell, it was hitting a few tiles, it was nice, but this new spell that we just calculated was 10,000 points, so that's way better. So in this case, we want to replace the previous spell with the new one, because the new one is way better, it's a better choice for that turn. So let's replace it. I'm just going to replace the AI spell casting structure with a new structure completely. I'm going to feed the spell we want to cast. I'm going to feed the origin to cast that spell, because this information is based on an origin and a specific target. So I have my new origin right here, my new target right here, and I have the new score that we just calculated. And I'm also making sure that I'm making this spell right here valid, because we just found a new valid spell. So I'm checking this checkbox to say, okay, we found at least one spell that is good. Good. Okay, so that's it for the flow. I hope it made sense because I went pretty fast. But in short, we're casting a spell from an origin and a target. It gives us a bunch of attacked indexes. So we have, let's say, 10 tiles to attack. We're looping through all of them, checking if we attacked a unit. If so, we're going to increment or decrement the score depending on the score of the impact of that tile. So if I attack a specific unit, it's going to affect the score in a specific way. And then once I'm done affecting the total spell score, I'm just going to check, okay, is this score better than the previous one, and if so, this is my new spell that I want to cast. Good. Okay, that's done for this function. Now we just have to do the CalculateImpactScore function to be able to test all that. So let's do that one. And here the first thing I'm going to do is create myself 4 new variables. So 1, 2, 3, 4 new variables. And we're going to use these variables to affect the value of each of our points. So let's say we have the HP points right here, HP value. We are going to give them a lower value because let's say the unit have 2000 health points. That's a lot of points compared to, let's say, the amount of movement point the unit has. If the unit has only 5 movement points, that's pretty low compared to 2000 health points. So the stats are not really worth the same thing because you can either have a lot of them or very little. So that's why here we are adding a multiplier, a value multiplier on top of those points. So I have the HP value, MP value, AP value, and finally I have the killing blow value. That one is more obvious. We're going to assign a specific amount of points we want to add to the score in the case that we killed a unit. And now we're just going to set them some default values. You can set them right here on the right if you want to do it, but since I want it to be a little bit more visible for you, I'm just going to do it in the graph. So here they are. My HP are worth 1 point, my MP are worth 10 points, my AP are worth 5 points, and finally my killing blow value, it's worth 100 points. So if you kill a unit, it's giving you 100 points. That's good. Okay, and now I'm just going to reconnect my return node like that with a sequence. So here I'm just going to do all the calculation to determine the final score, and then I'm just going to return it right here. And now that we know the real value of all of our resources, it's time to calculate how much the spell is really costing us to cast. So I'm just going to move right here on the right, and I'm going to create myself a new local variable, which is going to be the cost. It's going to also be a float, and I'm going to set it right here. So the cost of the spell, how do we calculate that? Bon, okay, let's start by getting the requirements of our spell. So how many movement point, action point, and health point it costs us to cast the spell. We're going to add them all together, multiplied by their values to generate the real cost. So let's take the health point first. I'm going to multiply it by the health point value, and then MP multiplied by the MP value, and finally the AP multiplied by the AP value. So these numbers together, we can add them, and it's going to give us the final cost of our spell, the real cost. Technically, we could also take into account the maximum cast per turn and the cooldown turn count, but I'm not doing it today, so we'll see in the future. But I think it will also affect the cost of the spell, because they are different resources that we can take into account if we want to. And now the next information we need to calculate the score of our spell is to know if we attacked an ally or not. So I'm just going to create myself a new local variable right here. It's a boolean, and I named it is ally, and we're going to set it. So I'm just going to move on the right here and set it right there using the team index of both units. So if my unit that is casting the spell has the same team index as the unit I'm attacking, it means that I'm attacking an ally. It can be bad, it can be good. If it's a healing, well, it's good that I'm healing an allied, and vice versa. If it's damage, it's bad that I'm attacking an ally. So yeah, that's why we need to know if we attacked an ally or not. And now, okay, we know how much the spell costs to be casted, we know if we attacked an ally or not. It's time to calculate how many points it gives us to hit the attacked unit. So here it is. I'm just gonna move on the right a little bit to do those calculations. And the first thing I'm gonna check is how many points we are removing from the target unit. So here I have my spell impact, and we're gonna start with the health point because that's the one that makes more sense. We are attacking the enemy. We want to know how much damage we are doing and how much points is that worth. So I'm just going to take my modifier HP right here and do an average just like that, just so I know how much damage I can do on average. And then I'm just going to multiply that by the health point value. So if my health point are worth 1 point and my average is 50, this is just going to be 50. But now here's the tricky part. We want to know if this right here is a good thing or a bad thing, because if we hit an ally, that's not good. These points right right here are going to be negative. They are going to be subtracted from the total amount of points we want to give to that spell. But in the case that we attack an enemy, these are going to be positive because that's a good thing. We want to attack enemies. If we healed an ally, that's going to be positive also. It's a good thing that we heal an ally. But if we heal an enemy, that's bad, obviously. So yeah, here we have to check, okay, did we just hit an enemy or healed an enemy? Did we hit an ally or healed an ally? So yeah, here it is. I'm just checking, okay, is my average greater than 0? So is it healing? And if so, did we just heal an ally? And if so, well, that's good. That's going to be a positive result. But if we healed an enemy, that's going to be false because that's a bad thing that we healed an enemy. And vice versa, if we hit an ally, that's bad. And if we hit an enemy, that's good. And that's going to affect this multiplier right here. So I have a select node and I'm returning a float right here. So if it's false, I'm returning -1 because it's a bad thing. But if it's true, I'm returning 1 because it's a good thing. And we're going to use that to multiply our score to determine if we want to increment or decrement the final score. So right here, I'm going to multiply them together. First, I have to do an absolute because I don't want to be affected by the original sign of my healing or damage right here. It's only going to depend on this select right there. So here it is. Now I can multiply them both together and I can create myself a new local variable which is going to contain the HP score. And now we have to do the exact same thing for the movement point and action point, but I'm not going to duplicate all the code. I'm just going to create myself a new function for it. So I'm just going to select all those nodes right here. Here we go. So everything except the HP value, the isAlly, and the min-max modifier at the beginning. And I'm going to right-click collapse to function. I'm going to name it the CalculateSpellScoreAndUpdateSpellcasting. Here it is. I'm going to make it pure and rename my inputs and outputs. And that's how it looks. So I have my impact minimum maximum, I have stats value, I have isAlly as inputs, and then I have my score as output. Good, so that's way cleaner, and now we can reuse this little bit of code right here to calculate the score of all the other variables. So I'm just going to connect my minimum maximum and promote all of that into new local variables, just so we know the score of all the different statistics. And that's how it looks. So yeah, it's way nicer than if we copy pasted all the code. So I have my HP score, my MP score, and my AP score right here. They are all calculated using that new function we just created. And here I'm feeding the MP value and AP value for both those because that's the values that are associated to the different stats. And if we go inside the calculate stat score just to see, this is how it looks if you want to make sure that it's good. Okay, good. So that's done. Now we can go back right here. And I think it's time to test it. We didn't calculate the killing blow score right now, but we're going to do that after if everything else works. So I'm just going to go back at the beginning right here when we are returning at the end of the function, and I'm just going to return the final score that we want to return for this impact, and that's how I'm doing it. Okay, so yeah, I'm just adding the HP score, MP score, and AP score together. Then I can divide that by the cost of the spell, so we know how much the spell is worth in points, depending on how much the spell costed in resources. And then we can return that right here at the end. And if we did everything correctly, we should see the result in the game. So let's go see. Here we go. So now my units are on the grid, and if we start the combat, we can see if it works. Okay, we can see that my ranger attacked the chicken right here. The other one just ran away. That one healed himself. Okay, that's weird. The slimes are attacking each other. The bat is attacking. Okay, that seems good. The chicken's running all over the place. The other chicken is running too. Okay, that's interesting. Going to end my turn. Okay, the ranger attacked the priest. The ranger is running away. Ah, yeah, attacked the chicken first. The priests are healing each other. The slime's attacking. The slime's attacking again. Oh, it's going really fast. But yeah, all the units are, they seem to work. They seem to attack the other units and then end their turn. They are moving away. That makes sense. The AI is not the best. There's a few bugs here and there, and we're going to improve that real quick before ending the video. But overall, I think it's good enough for a first pass. But anyway, let's go do all the improvements before ending the video. So now, back in the Calculate Impact Score, the next thing I want to implement is the Killing Blow, because right now we have the Killing Blow value, but we're never using the Killing Blow score, or the variable that we didn't create yet, to affect the final score. So I'm just going to promote this 0 right here into a new local variable to create myself a new float that I'm going to name a killing blow score. And then we're gonna go at the end of the function, at the end completely, to determine the value of this score right here. So after doing all that, we're going to calculate the score based on how much chance I have to kill the other unit. So let's first check, okay, am I doing damage? So is this damage right here? Because if it's not damage, well, there's no chance for me to kill the other unit. So it doesn't really matter in that case. And actually, if we're not doing damage, I'm just going to set the killing blow score to 0. We don't want to affect the score at all based on that variable because we're not doing damage at all. So there's 0 chance for us to kill the other unit. So we're not gonna do any maths to try to determine how much chance I have to kill the other units because I can't. So here we go. It doesn't matter in this case. Now I'm just gonna move on the right to do the calculation to determine how much chance I have to kill the other unit, and this is the formula. Okay, that's pretty big, and I don't really want to explain it to you because I just did a bunch of trial and error until I found this formula. It's probably not the best one, but at least it gives us what we want. It gives us the percent chance I have to kill the other unit, and then we can use that percent to determine the value of the killing blow. So I'm just gonna go on the right here. I'm just going to connect my set killing blow right here after my branch, and then we just have to multiply the percentage I have to kill the other unit by first the score, so the killing blow value, which is the amount of points we want to give in the case that we are killing another unit. So if I have 50% chance to kill the other unit, well, I'm going to receive half of those points. That way it's going to affect the result. And the second thing I want to multiply it by is the check to see if we just killed an ally, because if it's the case, that's not good. We just killed an ally, or we're about to kill an ally if we target that tile. So we want to really affect the score negatively because we don't want the AI to kill its own allies. That's not good. So in the case that's an ally, we're going to multiply it by -1. Otherwise we can leave it to positive because that's a good thing that we kill an enemy. Okay, so that's it for the killing blow score. I can just zoom out a little bit so you can see the result. Here we go. So now when our AI tries to cast the spell and it has the choice between 2 units, one that is alive, the full HP, and the other one is almost dead, it's probably going to prefer targeting the one that is almost dead, and that's exactly what we want. We want the units to kill each other. And now just before I go test another time, I'm just gonna go all the way at the beginning of the function right here. We have the MP, AP, and HP values, and I think that the MP and AP values are a bit too high, so I'm just going to change them. I don't know, for the MP value, maybe we can put it down to 5, and for the AP value, let's say 3. I'm not sure that they are the best values, I'm just testing them out, but we'll see if it looks a little bit better. Okay, let's go see how it looks in the game now. Okay, so here I have all my units, and I'm going to start the combat to see how it looks. Okay, first my ranger attacks my warrior and then run away. That's good, that makes sense. My priest, okay, it healed itself even though it was full HP instead of attacking the other units, so that's pretty weird. We have to fix that. And then it didn't move at the end of the turn, so that's a little bit weird too. The chicken ran away, the bat hit the warrior and then run away. That's good too. I'm just going to skip my turn. Okay, the ranger ran away even though it was able to attack my warrior the turn before, so it's weird. It should attack the warrior again. The priest didn't move at all, so that's weird too. We have to change the behavior of the priest. Okay, I guess other than that it makes sense. So we have the priest that keep healing itself even though it's full HP. The ranger doesn't attack, it's just running away. And then we have the priest that doesn't move at the end of its turn. So we have these 3 things that we want to fix. So let's stop and go fix them. And the first thing I'm going to start with is the priest continuously healing himself over and over and over and over, even though it's full HP. So the reason why it's happening is just because we're never taking into account that it's possible that the max HP is reached already and we're not really over healing, like healing over the maximums. So that gives us an invalid score in return. So what I'm going to do is just go where we are setting the HP score right here. So we are setting the HP score. This is based on the min-max modifier HP, but that modifier is not completely right in the case that the unit is almost full HP or completely full HP. So what we're going to do is just modify the way it's calculated, but we don't want to affect the other ones. These ones are good. So what I'm going to do is just disconnect this one right here. We're going to disconnect the HP from the other ones. I'm going to move it on the left a little bit so we can focus on it without having these other one in the way. So I'm just going to realign a few things so it looks a little bit nicer, and then I'm going to go on the left right here to focus on the HP score. And now what do we want to do? Well, we simply want to limit the minimum and maximum range right here, depending if first if it's a healing, because if it's not a healing, we're just going to leave it as is because that was not the issue. But if it's a healing, we want to make sure to limit the range based on how much health point is missing on the target unit. Because if the target unit is only missing one health point, well, we're not going to heal him by 500. It's just one health point missing. So we're just going to be able to heal him by one, which is going to give us a way lower score. And that's exactly what we need to fix the problem. So first here, we want to do a select because we want to choose, okay, do we want to use the original range in the case that we're not using a healing? So right here, if we are doing damage, we're gonna use the original range. So if it's not a healing, so right here I'm checking, okay, is my range a healing? If it's true, it's going to be true right here, which we're gonna change in a second, but otherwise it's going to use the original range because we don't want to affect the damage range. It's good, that's not an issue, so we are not going to affect it right now. But in the case that this was a healing, we're gonna build a new range completely, so I'm going to make a new endpoint right here, and this range is going to be based on how much HP is missing on the unit. So right here I'm going to check, okay, what's the difference between your max HP and your current HP? That's going to give us how much HP we are able to heal you. So if we are only able to heal you one damage, well, it's going to be a maximum of one healing right here. And to achieve that, we simply have to use the min nodes right here. So we are taking the original range, we're doing mins to compare it with the maximum heal we are able to heal the target, and then that's going to build a new range completely, which is going to be limited to the maximum healing we can apply. Because let's say the unit has 5 health point missing right here, and the range the initial range was between, let's say, 10 and 50 healing. In this case, with the minimums are just going to compare with the 5 that is missing from the unit. So which is the minimum between 15 and 5, it's obviously 5, and then the minimum between 50 and 5, it's obviously 5 again. So that's just going to make a new range from 5 to 5, which is exactly what we want. We are just going to be able to heal the unit by 5 health points, which is going to give us a way lower score than if we think that we are able to heal him by 50, for example. And that should be enough to fix the priest healing himself over and over and over, because if the priest is full HP right here, it's going to give us a range from 0 to 0, because that's how much we can heal the priest, which is just going to give us a score of 0, because, well, that doesn't give any points. And now we have to fix the second thing, which is the ranger that prefers just running away instead of attacking the other enemies. So that's a bit weird, and that's just because of my values for my movement point. Again, I think they are still a bit too high, but not in this function actually. It's going to be inside the CalculateSpellCastingLocation right here. At the beginning, we were deciding a default score, so a base score we want to start with, and here we are multiplying it by -5 every time we ask the unit to move one tile to be able to cast the spell, and I think that's a bit much because my spells are not doing that much damage right now, so -5 is huge. So instead I'm just going to, let's say, -0.5. That's not a big value, it's just to be tipping the balance either on the left or on the right, and help us decide which tile is the best in the case that multiple tiles have the same exact score. So that's just going to add a little something on top of it to help us decide which one is the best one. And the third thing we had to fix is the priest not moving at the end of its turn, and I think that's because of an issue I have in my pathfinding. So in the find best index in reachable right here, I have a little issue in my logic, and we're going to modify it to improve that a little bit. And actually the problem is right here in the GetAllUnits, because in my priest is trying to move towards the closest ally, and in that case when I saw the problem, the priest was alone in his team. It didn't have any ally, so it didn't have any targets to tries to move towards, and that's not good. And that's actually going to be the same issues when we are trying to move away from the allies, for example, because if we don't have any allies in the team, it's just going to break the code right there. So what I'm gonna do is just for now, it's not the best logic ever, but in the case that we don't have any allies in the team, we're just going to use the enemies instead right here, because we're always going to have enemies in the combat, otherwise the combat will be completely ended. So that's why here I'm just going to make sure that the code doesn't break, and we are then going to use the enemies instead of the allies, even though in this case it doesn't really make sense to ask the priest to move towards the enemies, but whatever, at least it's not going to break the code. Perfect, let's compile and save, and now we can go see how it looks in the game now. Okay, good. This is how it looks now. The priest, okay, move and attack the chicken. The ranger is going to go out of its way to try to kill the chicken because it has a chance to kill it. The slime tried to attack both units at the same time, so that's good. It worked. The bat is going to try to move. Okay, it's not able to reach anybody, so it's skipping its turn. That's fine. Going to end my turn again. The priest is healing itself. The ranger attacks the bat. The slime attacks the warrior, chicken runs away, the bat attacks both units at the same time because it's able to, so that's good. Okay, my AI seems to work, so that's good. It's not the best AI in the world, but at least it seems to work, so that's pretty fine. I'm just gonna say that I changed a few numbers again, so if I go back in my BP unit AI right here, I changed those values right here, so my multipliers were way too high still because my damage numbers are way too small right now, so that's the issue. I changed my value here to minus 0.1 and also my multipliers right here at the bottom are just 1.5 instead of 3 and 5 that I said. So yeah, because my HP values are way too small, so we don't need the big multipliers for now. Good. Okay, so that fixes all the issues and it looks pretty nice for now, but I still have something I want to show you, so I'm just going to redo my grid a little bit. And the thing I want to show you is a performance issue. So here in the top right corner, I have my FPS visible, so we can see the result. And now with my slimes on the grid, I can try to cast my the slime ball spell. So we can see here, it's not an issue. The slime ball spell is pretty small. So if I ask my other units to cast it, they are casting it. Actually, it's not casting it. Okay, here we go. It's casting it. And it doesn't affect the FPS at all because that's a pretty small spell. It's a pretty basic spell. So that's not an issue. But what if we go in the data table and we update the pattern of the spell? So I'm going to make it super big. So a square, a really big square. Here we go. So now if I go back in the game, I can see that if I select my spell, now I have a ton of tiles and a ton of AoE. So now if I ask the other units to cast it, it should take way more time to generate the result. So I'm just going to end my turn. Here we go. We can see that the game froze a little bit. Yeah. Oh wow, that one froze a little bit more. It just even went into an infinite loop. So that's not good. That's not what we want at all. We want to make sure that if the spell takes too much time to calculate its result, it's just going to continue the game flow as usual and wait for the result other than just freezing the game and stopping the game completely. Because that's not good, and we're gonna fix that real quick. So let's go back in the BP unit AI, and that's gonna be inside the spell casting graph right here. We have the 3 loops right here. We are looping through all the possible spells. We are looping through all the target index, origin indexes, and then through all the target indexes. And that's a lot of looping. And inside that, we have all the attack indexes. So that's even more looping. So yeah, that's a lot of looping. That can really cause a big performance issue, and that's really not good. So what we're going to do is just simply add some delays in the loops, in between the loops, in the case that we calculated for too long. So if we calculated for, let's say, the same thing we did for the pathfinding. So if we calculated for more than 15 milliseconds, we're just going to add ourselves a little 0.1 second delay. That way, we're just going to wait. Okay, we did too much for this frame. We're just going to wait the next frame. Okay, next frame. Okay, can continue the calculations and then wait a bit and then continue and then wait a bit and then continue. And that way, it's not going to freeze the game and or crash the game completely. And to do that, I'm actually going to create myself my own for each loop. A for each loop that I call a manual for each loop that we can call manually. So we can tell it, okay, go to the next loop, go to the next loop, go to the next loop. Oh, okay, wait a little bit. Okay, now you can go to the next loop, go to the next loop. We're going to have to tell it manually, okay, go to the next one ourselves instead of just having the loop going to the next loop over and over and over until it reaches the end. We're going to have to tell it ourselves, which is exactly what we want because we want to be able to wait between each iteration if the the previous iterations took too much time. So let's create ourselves our own for each loop. But I'm not actually going to start from scratch. I'm just going to use the current for each loop and I'm going to modify it a little bit. So let's just double click on the for each loop. It's going to break us in the engine code. So that's in the engine. Don't touch anything in there because this is inside the engine. It's not in your project. So if you break it, it's going to break the engine for all your projects. That's not good. So don't touch the code in there. That's why it says here, don't touch anything. And instead, we're just going to duplicate this code and then we're going to reuse it. So what I'm going to do is click on the browse button in the top left corner right here. It's going to bring us in the engine code right here. We have the standard macros. This is containing the for each loop. So we're just going to duplicate the whole library. I'm going to go in my project, drag the standard macros inside the utilities folder here in my core, and I'm going to copy it. I don't want to move it because it's going to break the engine. So let's just copy it there. I have my new standard macros asset right here. I can just rename it BML for Blueprint Macro Library, and then underscore utilities. Here we go. So this is mine. I can open it, I can edit it, and do anything I want in there. But in the standard macro ones, we don't want to do anything. Let's close this one before you do anything. You don't want to do anything in there. We just want to modify our own library. And actually here on the right, we can see that there's a lot of function in there. We have the for loop, the while loop, the flip-flop, we have everything in there. The only one we are interested in is the for each loop right here. That's the one we want to modify. We don't want to modify any of the other ones, and actually we don't want to keep the other ones because there are already functions in the engine that have those names because we duplicated the library, and we don't want to keep those, otherwise it's just going to be confusing. So what I'm going to do is just delete all the other ones except the for each loop. So we can delete all the math ones, the networking ones, and the transaction ones. We're just going to keep the for each loop, and I'm actually just going to rename it also because there's already a function in the engine that has the name for each loop, so we're just going to rename it so it's not confusing. So manual for each loop, here we go. And now for the changes we have to do, well, it's not that much because the part that is responsible to go to the next loop is the sequence right here. That's the one that is first executing the loop body right here, the loop body, and then afterwards it's just going to go to the next loop, again and again and again. We want to do that manually, so instead of having the sequence right here, I'm just going to connect the assign at the beginning. So in the inputs right here, we're going to create ourselves a new input, which is going to be an execution pin that I'm going to name next loop. We're going to have to call the next loop every time we want to go to the next loop, and then I'm just going to delete the sequence because we're not going to use it. Delete the sequence and then just reconnect the loop body like so. So now we have a for each loop that is completely manual. We always have to call the next loop, otherwise it's not going to go to the next loop at all. Perfect. Okay, good. Now we can save the macro library and go use it inside the BP unit AI. And now if I right click and I search for manual for each loop, we can see that we have the new for each loop we just created. So here it is, and I'm going to use it to replace all my other loops. So I'm just going to reconnect them like so for all the loops. So I have this one, that one, and this one right here. I'm just going to replace all of them. Here we go, so that's how it looks. It's pretty similar as before, but we now have the manual for each loop here, here, and here. So it's pretty similar, the code is pretty much the same, but right now it doesn't work anymore at all because the manual for each loop is never going to the next loop because we're never calling the next loop pin right here, and right here. So none of them are going to go to the next loop. So we're gonna fix that real quick. So here, once we're done calculating the spell, we're just going to go to the next loop because that's how the for each loop works usually. So I'm just going to go from the end to here. And we're going to recreate the original flow. So right here to there. Here we go. So we're calculating the score for the spell, and then we're going to go to the next loop as before. So that's super simple. Then once that manual for each loop is done, we're going to continue the next loop of that for each loop. So I'm just going to take the completed and connect it back to the next loop right here. And then we can add some reroute nodes to make it a little bit cleaner right here, right there. Here we go. And finally, we're going to connect the last manual for each loop right here. I think it's a bit overkill to do them all like that, but whatever, it seems to work. So I'm just going to connect them back to the beginning. Here we go. Here we go, here we go. So now that's back to normal. Everything should work as before, but it's way more ugly. But anyway, the logic is pretty straightforward. We execute this loop, it's going to go here, it's going to execute the loop body here, it's going to execute the next loop, the loop body. Once this loop body is done, it's going to loop back to the beginning of the loop and go to the body. So it's going to do that little loop here over and over and over until the for each loop is over. Then once that one is over, it's going to complete and go all the way back at the beginning right here. And then it's going to continue the loop body again and again and again until it's completed. And then once it's completed, it's going back to the first loop, and then it's going to execute the loop again and again and again until it's completed for real and goes all the way at the end right here. So good. Okay, now let's just go see to make sure that we didn't break anything. So I'm just going to add a few units on the grid. So I have my one unit that is not an AI and then a few AIs. Then I'm going to start my combat and my turn, and we can see, okay, the AI is moving. Okay, this one is moving too. It's casting its spell. Okay, that's good. We didn't break anything. Perfect. Let's stop, and now we can go back in there to add a few delays here and there. And to do that, I'm just going to create myself a new macro. So new macro right here, delay if taking too much time. That's the name I'm giving to the macro. So this macro is just going to wait if I'm taking too much time right now. So it's just going to check, okay, how much time did I calculate? Okay, that's a little bit too much. Just take a break. Okay, now we can continue. But to be able to detect if the code is taking too much time, we need a new variable to remember when is the last time we called this delay function. So what I did is just creating myself a new variable right here in the bottom left, the time of last delay. It is of type date time, and that's going to remember the time at which we called this function. And then I also added an input and an output pin, both execution pins. That way we can connect both the input and the output together like that, with the flow in the middle, obviously. And now for the flow of the macro, it's not that complicated. Actually, we're just going to first check how many milliseconds has been since the last time we called this macro. So here I'm taking my now time, so the time it's currently right now. I'm checking the difference with the time of last delay, so the last time we called this macro. It's going to give us a result in milliseconds, and we're going to compare it with 15. So if it's been more than 15 milliseconds since the last delay we called in this macro, we're just going to take another break because it's been too much time. Otherwise, we're just going to continue the flow. So if it's false right here, it's because we didn't take too much time, so that's good, and we can simply execute the rest of the logic. But if we worked for too long already, we just have to take a little break, so a little delay right here, 0.1 second, we're just gonna wait, and then we can simply re-update the variable with the now time. So it's going to be updated the next time we call this macro again and again and again. So every time we are re-updating the variable, that way the comparison right here is going to work. And finally, we simply have to reconnect the flow right here at the end because we still want to execute the rest of the code after the little break. Good. Okay, so that's it for the macro. That takes a break if we were working for too long. Now it's just time to go use it. So let's go back in the graph right here, and we're going to connect it in between every iteration of our loop. So right here, I'm just going to connect my new macro right here in between. So after my loop, I'm going to wait. Okay, hasn't been too long. Yes, no, yes. Okay, let's take a break. Okay, now you can continue to the next loop, and we're going to do that for all the other ones. If it hasn't been too long, it's just going to go to the next loop automatically, which is good. That's exactly what we want. We just want the code to take a break if it's taking too long. Here we go. So good. Now we just have one last little thing to do, and it is to initialize the default value of this variable at the beginning of the flow, because right now we're not doing it. So I'm just going to move this out of the way a little bit and connect it like so right here. So right here, we're going to take the time of now, so the current time, we're going to set it into the new variable. That way it's going to be good the next time we are calling this macro. Perfect. Now we can compile, save, and go see if it fixed all the issues. Here we go, so that's how it looks. Now the units should all play their turn normally, so we can see the rangers seem to work, the priests seem to work, they are attacking each other, and that's pretty good. And now when it's the time for the slime to play its turn, we can see that it didn't freeze the game and it didn't crash. My FPS is still pretty good, it's still above 100, so that's pretty good, and I'm recording at the same time, so obviously I'm taking more performances, but yeah, at least it doesn't crash the game. It takes more time to calculate and decide where it wants to move and cast its spell, because I really made my values way too exaggerated right now. My values in the data table are way too huge. That's not going to be the case in the real game for sure. But for now, yeah, my slimes are pretty slow. They are taking way too much time to calculate. We can adjust the milliseconds and also the delay between iteration if we want to. But that's just for later if we want to update those values. For now, I'm not going to change anything because I'm a little bit tired. This video has been a little bit longer than I expected, and I'm starting to lose my voice. So yeah, that's not good. But anyway, that's it for today's video, and I'm gonna see you in the next one. So bye bye!